Ladies and gentlemen, welcome to my shop. My name is Keith. I'm your host. On with the show. Today's project is another marine component here, propulsion component. This is a strut, stainless steel. This was fabricated out of three pieces: a barrel, a web, and a palm. And those of you that don't know what a strut is, all right. And so anyway, this project was sent up to us from New Jersey. Marina sent it up to us. They knew of us and contacted us and asked us if we wanted to take a look at it and repair it for them. Story goes, no names included, to protect the innocent. Owner of the boat had an accident. Another marina hauled them out and performed work. Boat went back into the water, and then it was hauled out again by the marina that sent it to me. They inspected. They had an issue where they couldn't rotate the shaft by hand. Pretty good indication right there that something's wrong. Further thinking, they're looking at the strut, and that's when they called me and they asked me if I'd take a look at it and perform the repairs as needed, if they needed any. And this is what I found. There was a couple things that I did need right off the bat, because this is not a straight inline strut. This is I believe this is a starboard strut here, and the hull comes at an angle, and I needed to know the actual angle required by this vessel. So they gave me that angle within a day or so. The next day, and I set up my protractor, and when I hold the palm down, which the palm is bent on the bottom side, I knew that right away as soon as I unbolted it from the board. The original manufacturer of the strut machined the bottom of the palm to be square. When they first made it, maybe even needed to take a little bit off of it just to fit it in there and have the right height on the barrel. There's a couple different reasons why they might have done that, but most of the time it's they don't know, or they're not capable of straightening that palm back out in the press. Which, if I manufacture a strut, I have a rig, I set it up in here, and then I press the palm back square. So anyway, I know it rocks back and forth, and when you hold it over to the one direction, we're almost exactly right on that line. So when I go ahead and straighten that palm here in the press, I'll be able to make that angle exactly what it's supposed to be. And it does look pretty darn straight and square on this side, but the leading edge of the strut, there's a little rocking action going in on one side, so I know that there is a slight little bow in here. We'll straighten that out. While this was sitting over on the bench over there, I noticed that the barrel by eye does not line up with the strut. When you make a strut, you have a palm, and then your web, and your barrel, and your web comes up and meets your barrel. So I grabbed my center head and my scale, because I'll be able to hold this on the barrel. So what I had to do is put a little Sharpie mark right here, which was dead nuts onto that web right there, and then I can hold my center head on the outside here and hold it on that mark, and then I could see that that line does not follow that line there, meaning that the barrel is rolled in outboard, and it needs to be rolled back inboard. I also confirmed that because I know that this is a 1/2-inch web, and this is 3.5-inch diameter here. So I took half of the difference, 1.5 inches off the side here, and the scale sticking out just a little bit over 1/4 inch there. And on this side here, if I hold it against the barrel and hold it parallel to the parallel, I'm matching that distance right there. So that'll confirm, and I'll be able to roll that over. All right, so we have a slight dish in here, slight bow in the web, the barrel's rolled over, and then I actually got to looking at it because they asked me to put a bearing in it. Well, they sent me a virgin bearing, and I can only imagine what the one looked like that came out of here. All right, because I took my snap gauges and I measured up and down, and I got something like 2 inches 570, and I took a side to side measurement here, and I got 2 inches 607. This is a 2 5/8 bearing. Okay, so this is 625, plus these come 2000s heavy, so you got 627. There is no way that you could press a virgin bearing in there. And it kind of, I kind of knew that it wasn't right off the bat, because this is raw extrusion surface in here. This bearing has never been bored for the proper fit on cutlass bearings. So every time this customer would come into replacing a bearing, which bearings should be replaced every 2 to 3 years. This is rubber. It wears, it dries, it gets hard, it cracks. All right, it's not a forever piece of material. This is a consumable item. That was for those of you that insist on running them for 10, 12 years and wonder why your shaft is worn out. All right, back to the strut. All right, so what I got planned: straighten the palm, straighten the web, roll the bearing, the tube here, the barrel, and then line bore it. We'll line bore it over in the lathe. The line bore is going to be touchy because, one, it's not round, and it's almost out to size. So it's going to be a little bit tricky to set that one up, but we'll be able to handle that. And we'll be able to put this strut back in its proper configuration for the customer. So let's get going on this project. Well, I got excited about starting a video and forgot about turning my microphone on, so I'm going to have to lip sync this bit here. We're focusing right on that little bend in the strut blade itself. And we use our straight edge to do a lot of eyeballing ourselves so that we can pinpoint exactly where that's at. And we check the whole blade out, and we just work that one area right between there and there. All right, the rest of the blade all looks really good. So we're just going to focus that one point. And we'll take care of that blade before we do the palm and also the barrel. Now I like to use round stock to pinpoint and straighten a lot of the strut blades themselves, because I can get it to really pinpoint the push but not be a sharp edge. Sometimes a block will want to follow the push of how it sets against the ram head, and sometimes it puts little creases and marks in it. So I'm going to put the ram against the rod and use it to pinpoint the location I want to bend. Now this is real close to the palm blade, so we're really working in close. And I think I'm going to try to hold it out a little bit there, but you don't want your finger stuck in there. Alright, so I find parallels to stick in there until I get it sitting exactly where I want. No, that's too high on the blade. We need to get it down in there farther. So I find something skinnier and get that in there. And even that might be a little too fat. We come down and we use our scale and we hold it on the other side, because you need to see how you're bending it. And it always has, stainless always has a memory, so it always goes past and then springs back. I'm not really happy with where it's at, and I need to pinpoint it more. So I'm going to put the slug right in and right tight. Now, I'm not in the middle of that blade. I'm really off to that leading side there. Also, too, you see how my ram pivots to the side a little bit. It does that a lot, especially when I'm using the rock fixture in some of my videos. You can see it really moving to the side. I've never bent that ram. It has a lot of flex at that length. It's very forgiving, and I've never had to replace my seals on the cylinder that I rebuilt. I rebuilt that. That's a used cylinder in that hydraulic press. Come out of a thumb on an excavator. Alright, I'm pretty happy with that position right there. And I got that out of there. Looks good. I'm happy with that. We lowered our table down. We pulled out the center section, which is big piece of 3/4 inch plate with some 1-inch webs welded across it to support it underneath. The center one has that center hole in it. So this lets us put in a couple big parallels we have that spread across the rail. Now, the hydraulic press between these two channels on each side is two 18-inch long pieces of pipe. So it's 18 between the centers here and about 14 between the standoffs that I have going through here, 4 places. These, between the pipes inside and the all threads holding everything there, keep this press from these webs spreading or twisting, and gets the ultimate strength out of my channels on the side. It also lets me have a larger span so that I can do things just like what we're going to do right now, and that's drop this strut right in here upside down, right on these parallels, and then we can work this surface right here. Alright, so we're going to take a look at it, but it looks like pretty much right down the center needs to be our push right there. But we're going to study it and look like if we need to add it a little bit more to one side or the other. Meaning we'll look at the flatness to the bend and then the other direction here as well. And we want to see if one or the other is closer to one side or the other of this web right here, and it'll make a difference on that angle changing between the strut blade and the palm. Straight edge here, and I'm seeing this real solid, real flat, and this is the outboard side. The strut is hanging down and I'm on the aft side. You're on the forward side. Alright. And by the barrel roll and everything else, when we hold it up, it looks like it was forced or bent outward. And if we come in here on the inboard side of the strut center, we can see there's a hollow dish in here. Hollow dish. That's because these 3 studs out here holding the blade were the main reason why the force was put on these 3 out here. These 2 in here weren't really doing too much, and when that stress went like that, it actually bent this part of the strut right in here, and this side remained flat because it was pushing against the outside of the hull. Alright, we may not be able to take any of this dish out, but we'll be able to press the strut down so that this flat surface will match this outside flat surface over here. And by doing that, you can see from center of the strut out to there is, quarter inch there, a little bit less back here. About 3/16 in the middle, quarter inch up there, 1/8 inch back here. So we're going to have to get this in here, and actually it kind of shows the difference right in there as well. got my power set up. I've angled this slightly so I can get a little bit more distance, as much distance as I can get this strut back against this side here, so I can be as close to this face of the strut. Now I run a 1x3 parallel, and that's what we're going to be pushing on, and I use it in here so that it spreads that load out, and hopefully it gets more over here on this end here. Now we can we can take and put an added support in behind this beam here if we need to, so that we're pressing down on the parallels themselves and not so much on the web, and we can focus more pressure out here. But we're going to try it just like this first. Now we're going to hold our edge on here, and we're going to eyeball the clearance in here, and we want to watch that go away, and we'll come down to it, and then we'll come back up, and we'll see how much spring it is, and then you have to work how much past there you're gonna take it, so that when it springs back it's flush, and that's kind of how we're going to be playing with this. Okay, we're going to have to spread our parallels underneath here a little bit because we're not getting quite the action there. Okay, let's give that a try. Okay, that lessened it down to about 100 thousandths over there. Like I said, we're not going to be able to take too much of this dish out of here, but we'll make that flat contact over here. We want to double check all the way across here. Alright, looks like we're pretty well touching all the way. You know, we may not be able to get it any flatter than that. We're perfect all the way up to about right there. We put this under this end here so that we can pivot it like a toe clamp. Because we want to only focus it in this area right here. I'm happy with that. Now we're going to be drilling 4 set screws or jack screws that will be able to come up and underneath here. And when they hold this against the hull, they'll be able to adjust those so that they get the alignment of the strut the best it can possibly be, and then goop this thing, you know, drop it, goop it, put it back up there, and they'll be able to set it in place so that it has the best alignment from the bearing through the through hull up to the engine. And then after that, they'll have to do the final alignment on the engine. You always align, your last alignment is your drive to your driven, and this is the driven. Okay, we're just lowering our table back down so we can put the centerpiece back in. It's a pretty heavy centerpiece, so I like to have my table down low so I don't have to lift it so high. These are the strong backs I have welded underneath here. Now we can take a look at our strut, and it's not rocking around like it was. Okay, this might tweak your mind a little bit here. So I set up the protractor to the proper angle, the angle that was given to us by the marina down there. They've double checked the port side, how it's hanging in there, and also the palm angle to plumb with the boat sitting there, with all consideration of how the boat is blocked and all of that. So plus or minus a certain amount of air, that's the angle that we have and that we're working on and working with. This straight edge here I've got along this edge of the web or the strut blade. This is a 1/2 inch, so I slide this in out here in front because we want to slide another tool behind here, but there's touching there, but we're going to back this off so that I have a 1/4 inch in here, just a skosh more. Okay, roughly a 1/4 inch in there. So this should be center line from this palm to the center of the barrel. Now remember, we were looking at this and we had our center head here, and we had this lined up with where it contacts with there, and it's showing us that this is not center with the actual web. That's correct, but it is actually center with the palm, because when we bring this and we match this angle right here with the angle here, this follows up and comes center of the barrel. So regardless of how they actually put the blade in here, which is a little bit off center, so it's not gonna actually be cutting through the water totally true, but it is holding the barrel in line. But you couldn't see that until we straightened that palm and the little whoop we had at the very beginning in the center piece there. So all indications say do not straighten or do not try to remove or put this center of that web, because that's not where it needs to go. If we were to put it center of that web, we would be rolling this over a 1/4 inch off a center line. All right, on to our next step, and we're going to go set up the lathe, and we're going to line bore this to fit the bearing. The strut is as straight as it's going to be, and in proper mounting configurations right now. So we're going to bore this, and then we're going to put the set screws in the palm and press that bearing in, and this should be ready to ship back. We put our line boring jig up on the table, and we have two options. We can run them close together right here on this side of the carriage, or we can run this one here over on the front side and run this one here, or run that one there and this one here. There's three various widths that we can hold these two supports for line boring in here. Now, instead of having it's open on the top because we built it to do struts as well, complete built struts. After the web has been welded to the barrel, you can then line bore that barrel to fit the bearing. Okay, we took this is a 2-inch bar. Our OD of the barrel is a little bit egg-shaped because of the weld on the outside as well as the inside there, and it's 3.5 plus or minus a little bit, and a coating of prop scum. That's what I call it. So we took 2-inch from the 3.5, comes out the 3/4. We put a 3/4 inch spacer in there, and we kind of gave ourselves a rough alignment for holding that strut in the center. Now we just slide our bar back, we slide our carriage out, slide our tailstock down, and let's slip the strut right in there. Alright, now we can pick to bore it from that side or the other side, doesn't matter. We can put it in either direction. That was pretty close. Alright, there's enough straight right here we can grab the barrel just like that. Let me just tweak out on this a little bit. And we're holding it in place. Alright, we're going to get our wrench. I'm going to slide the bar in, and then we're going to indicate this barrel true with our axis of our shaft. Alright, I set up my small Noga. I usually run over on the Rutland with the finger reaching in here, and then my Intrepid mounted up on a custom little rod on this mag base right here, and I rotate them around 3/4 of the distance. I'm within 5/1000ths, meaning from about 3 o'clock, 6, 9, and then all the way up between 11 and 1 o'clock, and directly on 12 is an increase of about 30/1000ths where that weld bead was put in there, where it sucks it in. Alright, and that of course is going to be the majority of the material is probably going to come out of that side right there. And then just a light skim around the sides and the bottom. Alright, we're ready to pull these indicators off and put our tool bit in. This is our 2-inch bar we made several years back and is in some of our earlier videos. Okay, this has an adjustment down here. I've taken out a ball that was in there, a ball bearing, and it sits in there, and the butt of the tool bit goes against it and brings it out farther than the standard adjustment. The standard height right now is the regular standard tool bit is down against that adjustment, and I loosely put the bit in there. I rolled it over to this side here. I slid the tool bit out to where it touches the side. Bring this back slightly, the carriage. Tightened up my set screw, and then I lightly just brought the bottom of the adjustment up to the bottom of the screw so I know where we're at. Now I can bring and slide this inside, and I see the tool bit just comes inside and it's not touching. Now we know that we have a high spot here, but I want to just take a general sweep. So we're going to fire this thing off, and we're going to come in and we're going to touch off, and if it looks good, then we're going to let it run through. Okay, here we go. I'm just going to touch out by hand right now. Okay. I can hear harmonics in there, so I'm going to do a couple things here. I want to slow it down. I'm going to just make sure I'm really tight in the chuck. We're tight there. Make sure our tailstock is tight. Good pressure there. Okay, we can't afford to have any harmonics going on, and I think maybe the rake angle or the leading edge is, for stainless, is probably too much tool pressure. I think I'm going to come up with a real pointed, flat-faced tool bit.